Alright, problem number 6. We want to do a partial fraction expansion to write this fraction as the sum of 3 fractions. So first step in that is factoring. We want to factor the denominator so we can know the denominator of the 3 fractions we're splitting it up to. So what can I factor out in that denominator? Well, x cubed and x squared have x squared in common, so I can pull that out. X squared, what am I left with in my first term? Well, I'm left with x. What am I left with in my second term? I'm left with 2. If I multiply that x squared back in, I'd get x cubed plus 2x squared. So that's good. And what that tells me is that I'm going to split this up. Well, let's do it over here. I'm going to split this up into 3 fractions, 1, 2, 3. My first denominator, let's make that x plus 2. That's the easiest one to see. My next denominator, let's make that x squared. And then the less obvious thing to do is make that third denominator x. Anytime you have a repeated factor like that, x squared, you need to put one denominator for each degree, so an x squared and an x. If it were, say, x to the 4th, and you were splitting it up, you'd have 4 pieces. You'd have an x to the 4th, an x cubed, an x squared, and an x. You always do that. I explain in the lesson video why that is, at least a little bit. So these are 3 denominators. Again, the key with that squared piece is anytime you have a repeated factor, so something with a power on it, you always need to do one denominator for each power, so x squared and x. And so let's say we don't know what a is, we don't know what b is, we don't know what c is, but we want to find out what a, b, and c is. And so to do so, we need to find a common denominator and smush this stuff together. So my common denominator is going to be this original factor denominator, x squared times x plus 2. So if I look at my first fraction, a over x plus 2, I need to multiply that by an x squared over an x squared. Now my denominator is x squared times x plus 2, so I'm good. And if I look at this next one here, that needs to be multiplied by an x plus 2. So I need to do it in the top and the bottom. Let me give myself a little room. Now this last one, well, I need to multiply it by an x plus 2, but I'm still not there. I also need to multiply it by another x, because that will then give me, that'll combine and give me my x squared. So now I have a common denominator, so I can write everything as a single numerator, single denominator. So a x squared plus b times x plus 2 plus c times x plus 2 times x. And that's all over that common denominator of x plus 2 times x squared. And we're making the claim that this is equal to what we started with, negative 2x squared minus 4x plus 4, all divided by x cubed plus 2x squared. But I'm actually going to write that denominator as we've factored it, x squared times x plus 2. Now the key piece here is now we have a common denominator, which means we can ignore them and just look at the numerator. So we have now negative 2x squared minus 4x plus 4 is equal to ax squared plus b times x plus 2 plus c times x plus 2 times x. And what are we going to do with that? Well, again, this needs to be true for all x values. And so we can be crafty and we can choose x values that will eliminate some of our terms to make this easier to solve. So let's choose an x value that we know will eliminate some of our terms. Let's choose the x value of 0. Let's say x equals 0. Then what happens? Well, I have negative 2 times 0 squared minus 4 times 0 plus 4. So those are both gone. I'm just left with 4 on the left. 4 equals a times 0 squared, which is 0, so that's gone, plus b times 0 plus 2, plus c times 0 plus 2 times 0. And so that's all gone. So I'm just left with b and that 4 right there. So 4 equals b times 0 plus 2 is 2b, and so b equals 2. And let's do the same thing now with a second value that will cancel some stuff for us. Instead of letting x equal 0, let's let x equal -2. And again, I hope you can see where I'm choosing these numbers from. If I plug in -2, then on the left, I'm going to get -2 times -2 quantity squared minus 4 times -2 plus 4 equals a times -2 quantity squared plus b times -2 plus 2, which is 0. So b is gone, plus c times -2 plus 2 times -2, but -2 plus 2 is 0, so that term is gone as well. And so I can simplify this now. I'm just left with this stuff right there. So -2 quantity squared is positive 4 times -2 is -8, minus 4 times -2 is positive 8. So hey, look, that stuff's gone. That's kind of cool. So I'm left with then plus 4 equals a times -2 quantity squared. But -2 quantity squared is 4, so 4 equals 4a, and a equals 1. Sweet. So those are the easier of the two values to find. Now I need to find c as well. So I don't have any x value I can plug in to simplify things in the same way that all of that stuff simplified. But I do now know that a is 1. I do know b is 2. I can use those values, and I'm just going to choose a nice value for x. And in my opinion, a nice value for x is 1. I would choose 0, but I've already used it, so I can't use that one. So I'm going to move this stuff down real quick, and we'll do this last one. So here we go. Let's choose now x equals 1. Now if x equals 1, then I can write my equation, -2 times 1 squared minus 4 times 1 plus 4, hey, look, those cancel right off the bat, equals a, which I know is 1, so I'm just left with 1 times 1 squared, plus b, which I found to be 2 times 1 plus 2, plus c, which I don't know, times 1 plus 2 times 1. And let's simplify everything. On the left, -2 times 1 squared is 1, so I'm left with -2. Equals, on the right here, I have 1 squared is 1, times 1 is 1, plus, I have 2 times 1 plus 2. Well, 1 plus 2 is 3. 2 times 3 is 6, plus I have c times 1 plus 2 is 3, times 1 is still 3, so c times 3. And let's solve this now for c. Give myself some more room. Move this down once more. Here we go, solving for c. -2, subtract that 1, subtract that 6, equals 3c. So -2 minus 1 is -3, minus 6 is -9, equals 3c, so c equals -3. And I have found a, b, and c. I found that a equals 1, I found that b equals 2, and I found that c equals -3, which means now I can go up and I can look at this red equation right there, and I can plop in a, b, and c. So my partial fraction expansion is a over x plus 2, and a is 1 over x plus 2, plus b over x squared, b is 2 over x squared, plus c is a negative number, so I'm going to say minus 3 over x. And again, what we're saying is that this and what we started with originally are absolutely equivalent, and we have done our partial fraction expansion.